Maybe I can start. Yesterday in the MAIA workshop, we have like a really nice session presenting all the developments on ecosystem accounting from all the MAIA partners, excluding 3 countries that we are going to present today are Spain, Greece, and Netherlands. I'm going to present the work that we are doing in Spain within the MAIA. Before I start, 2 things. Well, I am presenting this, but we are a group, and I will especially like to acknowledge the work that Adrian is doing, because I am more on the coordination, but he is actually the one dealing daily, and all the hard work is done by him. And another thing that I wanted to highlight before I start is, these are not the Spanish account, these are experimental. So we are in MAIA proposing somehow ways of methods on how we can develop these accounts. I mean, I'm not presenting like any official ecosystem accounts from Spain. I'm just proposing some ways that we could develop these accounts for future works, and how this could be implemented into official regulations and into national statistical offices is a different story. So we need to differentiate between these 2 things. Okay, so as Tania from the minister was saying, and in Spain we have been working since long time at national level, working on mapping and assessment ecosystem and their services. We started actually in 2010 with all this the Spanish National Ecosystem Assessment, and then we moved to the economic evaluation of the services. And so when we started this MAIA project, it was really a challenge to convert all this, let's say, MAIA's approach of mapping and assessment into really accounting framework. So these 2 frameworks are very complementary, but there is some differences that needs to be clearly taken into consideration. Another important issue was that since the beginning, we thought that this was not a purely research project. So we need really to make partners with the Spanish ministry, with the statistical offices, to really, to have a dialogue with them and to really start seeing how we can develop this for future. So we've been doing this since the project started. So we have had several meetings. We probably need to have one final meeting as the country, what was the name? Country national workshops again. So we will have one, probably last one, to all of us, the SEEC, us in the university and INE and ministry will probably have one official final national workshop. Okay, so in Spain, one good thing is that based on these previous experiences, we did have a kind of national ecosystem classification, which for ecosystem accounting is very useful. So you don't have to rely on other kind of classifications. So we did have our system approved and more or less approved. It's not either official, but it was from the Spanish National Ecosystem Assessment. It was mapped and developed all these ecosystem types. One of the challenges from accounting perspective is how to link these classes of mapping ecosystem with, like, for instance, IUCN, which is the SEEA recommendation on. But we have found quite easily straightforward. So we have developed some kind of crosswalks between what is I put here in level 5 is our, let's say, our national ecosystem classification, and what in IUCN, in the SEEA recommendation, they're recommended this level 3 on functional groups. And yeah, we have developed some crosswalks, and I think it's quite a straightforward way of working. And actually we can go also to the MAIA's classification, which is probably going to be the one adopted in the regulation, in the EU regulation. So what I'm saying is that in the ecosystem types, we can either go to the SEEA or to the MAIA's, but it's good if you have a national classification to start with your national accounting. Another important point is what data sets at national level do you use? This took us a lot of time, and thanks to the Spanish ministry who provide us with this database, which is the LULUCF, Land Use, Science and Forestry, which is actually the one that the ministry is using for reporting on the climate change. So all the missions, and so this is the most comprehensive and high resolution information that we have in Spain. So we have it for 25-meter resolution pixel, and we have a time series from 1970 to 2015. And as you can see, it's really a mix of all kind of forest map of Spain, Corine land cover, crop and harvest map. So it's an aggregation of all these data sources into one product that is really useful for our ecosystem accounting. So this is the one that we have used to develop our national accounts. Going to MAIA, in MAIA, this is how we develop the proposal. It's a bit, not very updated, but in Spain, we have working, as you know, at two levels, at national and regional level. Initially, us in university should be working at national level, and then the colleagues from CSIC will work from Andalusia, based that they will report later. But based on after these 2-3 years of collaboration, we are working in one national account together that probably Jose Luis will report later. In terms of the accounts, we in the proposal decided that we will cover extent, condition, ecosystem surprise in biophysical and economic and biodiversity, but we didn't include assets. And more or less, we have been able to accomplish all the things that we put in the proposals. So today, this is what I'm going to report to you. Basically, this is the SEEA framework adapted from us. I'm going to only talk about the biophysical accounts, because then the CSIC team is going to present you the work that they are doing in Andalusia and in Spain in the monetary accounts. So my part is on the biophysical accounts. Well, the state of the situation in Spain is that at the national level in biophysical is that we have developed extent and condition, and it's finished. That work in extent and condition is, let's say, finished. Of course, we can always improve it and still working on it, but it's like the first proposal is done. And then we are working in several ecosystem services that is under process. And we're also working on biodiversity accounts. This is what I'm going to explain you. So this extent, condition, and some services and biodiversity, this is going to present you briefly in the next slides. So for the extent account at national level, this work has been recently published. So if you want, you can look at the publication. How ecosystem extent is changing as a national level accounting approach. So we really wanted to take the SEEA guidelines, the biophysical guidelines, and try to explore how to put that into national level ecosystem accounting. We developed these models where you can see where all the information comes. You have to define the ecosystem types, transformations, and all the outputs but I cannot. You have to read the paper if you want to have a better understanding. But we were able to develop the accounts for terrestrial ecosystems, for all terrestrial ecosystems, from 1970 to 2015. This was the LULUCF database that I presented, and we can report it from all these time periods. So we have all these time periods, and just to put you some examples of the maps and tables, you see the map from 1970 of the extent accounts, and we have produced the same for 2015, which you can see there is in the 3 spots that we have highlighted, there's quite a few differences. We have developed all the accounting tables based on the SEEA recommendations. So you have initial stocks, reductions, additions, and what is stable. So all the information that is requested in the SEEA. I'm putting here the information only for forest ecosystems, but it's done for all ecosystems. So we have all this information produced for all ecosystems. We also have ecosystem chains, so it's not only in terms of what area is changing from one ecosystem, but also how the flows between what is converting into from one ecosystem to the other one. Very similar what Flanders was presented yesterday. In Spain, as you can see, basically the major conversion between 1970 and 2050 is the conversion from annual crops to different types of forest types, that I would say. And we can have this also in this very boring and long 2-entry matrix that also Netherlands presented yesterday. So you have the same kind of ecosystems in the X and the Y, and you can see what are the conversions from one ecosystem to any other ecosystem. So all these numbers is the same that is presented here in a more graphic way. Okay, one thing that I didn't mention, this information is also explained in the paper. It was validated. For the validation that we use is Lucas. Lucas is a EU, let's say, real data on the ground. It's a network of information on the ground. So we tested our results, how reliable they were from the Lucas database, and results were reasonably good. So you can see the validation process also explained in the paper. Okay, going for the condition accounts, we did this only for forest types because condition is much more challenging than I would say than extent. It requires conceptualization for each ecosystems and indicators and reference areas. So it is really a big work to be done. So it needs to be probably done ecosystem by ecosystem. Like for instance, we had yesterday France and from marine ecosystem conditions, and that it was, let's say, similar approach. Basically, we have like phase 1, you select what type of ecosystems. In this type, forest ecosystems, you select a set of indicators to assess those ecosystems. I will explain you a bit more of that. Then you create a reference area. In this case, as these are natural forests, we were able to define reference areas. And based on the comparison between these indicators and the reference areas, you derive into let's say a condition index, which after some aggregations, you can derive into what is good or what is bad condition, and then all the reporting. This is under preparation. This publication is going to be, before the end of the year, is going to be published as well. In terms of the ecosystem the indicators that we use to assess, we followed, as I said, the SEEA EA recommendation, which is based on abiotic, biotic, and landscape characteristics. And as you can see, we have derived a lot of our indicators on remote sensing data, not only, but a lot of the data is based on remote sensing information. Based on the quality of the indicators and how these indicators are expressing the condition of what we consider based on an expert group, we weight the different indicators, try to balance all these different classifications of the conditions. For the reference area, we defined reference areas for forest as the best conserved forest areas that we have in Spain, which is IUCN categories 1 and 2. And based on our results from the extent accounts, that has not have any change in extension since 1970. So anything that has been not changed and very well conserved, we consider as our reference sites. So in those reference sites, we measure all the indicators and then we start to compare all the indicators with the reference areas. And these are more or less, after all the aggregations and all the work, this is more or less the results. So you have for 2000 and 2015, you can see that there is quite some changes, I would say. It's not the same for all ecosystems, but in general terms, and this is something that it was quite a big discussion within the group, we can see that a forest ecosystem in Spain, more or less, are getting even better, based on our, not too much, but a bit better than expected. These results also can provide you like with all these initial conditions, final conditions, the change between all the forest types, and we also have for each ecosystem all the condition tables, the condition accounting tables. Finally, on the ecosystem services on biophysical, we have, as I said, we have worked a lot in the last few years on ecosystem services mapping and valuing in Spain. So we have had a lot of publications and work done under this. But here I'm going only to report you on what are we doing in MAIA. Very recently, also this year, we have accomplished the Global Climate Regulation for marine ecosystem sequestration accounts. This is only for seagrasses at the national level in Spain. So we were able to account all the carbon sequestration for seagrasses at national level. And it was even developed with INVEST model, some kind of future scenarios and how this current situation will change under different pressures and the different scenarios. So you have there the publication if you want to check it. Now we are currently working on the terrestrial carbon sequestration accounts. For that, of course, we are the same that in the marine, but for the marine, it was only, let's say, the seagrasses. So it was a bit more not easy because the marine is always very challenging. But in here is a mix of all forests, I mean, different ecosystem habitats. And we are trying to assess all the carbon sequestration from from above biomass, like underground biomass, deadwood, and soil. For the biomass, the above and below biomass, we are using remote sensing data from this NASA information. The same for soil organic carbon, we're using global data sets. And for the deadwood, we're using the Spanish Ministry inventory monitoring network of the Spanish forest that they have monitored the deadwood in those sites. So it's a mix, as you can see, global and national data sets, what we are using to run this model. Yeah, these are still not yet published. We're under development, but we have already developed some maps and accounting tables for the carbon sequestration of, in this case, forest ecosystem. But we have done it not only for forest. This is done for almost all of the ecosystem types. One last very interesting work that we are doing together with Lars and Ilan is the recreational, on the cultural accounting, the aesthetic quality of the landscape. This actually was Lars and Ilan who invited us. It was not actually in our plans, but they thought that Spain was a good place to run a model that they had been using in the UK, and it was using artificial intelligence and social networks, trying to develop the number of pictures in Flickr and how people value those pictures, and try to make a kind of an assessment of the value of the aesthetic. At the moment, we have developed, we are going to run, it's under development, we are going to develop a national survey to generate a set of training data based on these characteristics for terrestrial ecosystem of the Mediterranean region of Spain. So we're going to ask a lot of people in Spain to value all these pictures, and let's see then what Ilan comes with that. Finally, we're also working, and this is on biodiversity account. So basically what we are doing is all the species that has been reported under the Habitats Directive and the Bird Directive, so Article 17 and 12 from the Spanish Ministry. We are trying to develop this information into some systematic modeling with using different models for environmental predictors and machine learning models to develop some species richness all for the entire territory. This work is also under development, but it's quite advanced already. So we have developed all these different groups of biodiversity and all these species. For all of this, we have maps and accounting tables actually for all of them. So for different time periods when the reporting has been done in Spain. Finally, I have to finish, right? We have put some of this information into the MAIA Accounting Explorer or Viewer. This is at least extent and condition are already there. The rest not yet, but probably will. And just to let you know, we are starting to produce, let's say, our own national ecosystem explorer, where we are putting all this information, and we have using our ArcGIS hub, and this is going to be available soon, and all this information is in a prototype system where we have developed some kind of information, put all this information into, and you can see some of the accounts that I just presented is already into our viewer, national viewer. So you can even have some of the tables, the graphs, and all this information is there. Okay, thank you.
Thank you very much, Fernando. At a personal level, I must say I'm really impressed by all the work done in Spain. It's fantastic that you've managed to develop all these accounts and also progress towards developing a viewer, etc. And it's, of course, also thanks to the involvement of the ministries and the statistical office. Unfortunately, yeah, our timing has been perhaps a little bit too tight, but we have only room for one question. So if there's anything urgent, either in the room or online, because I'm not sure, I cannot see the hands online. Now I can. Otherwise, Panagiotis and Janis, may I invite you already to prepare your presentation? Because I think everybody was overwhelmed by everything that you presented, Fernando. Yeah, well, you can sit here if you want, or whatever you prefer. Yeah.
Morning, everyone. After this nice presentation, I think that I will try to be as good as Fernando, but it's rather difficult. Anyway, I will try to explain you or to describe what we're trying to do in Greece on the biodiversity accounts. And this is prepared by Yanis Kokoris, a very good collaborator for the project and all the others. and me. About diversity accounting under the SEEA ecosystem account, the main concerns, the main questions or challenges we had are related to the scale of accounting, to the data availability, which data we have on a spatial and temporal level. One of the most important things here is the spatial scale, the spatial level, how to quantify this data. Now, according to the new version of the SEEA EA, the habitat-based biodiversity metrics, how the data we have obtained from various projects of the EU related on habitats can be used in order to have indicators. We try to integrate into current monitoring schemes and how all this could be integrated into current development strategies. So we started in Greece to have some proxy indicators based on the Greek flora. We have a very good database in Greece for 7,000 species and subspecies. We have 1,200,000 georeference data. So you can imagine that we have much information on the plant taxa. So you see here that we have the total species richness in our case study, which is the Peloponnesos for MAIA project, the total species richness, the endemic species richness. We are based on this information. And of course, here we have used the Peloponnesos area, where you can see the different taxa richness at the family, genus, species, and subspecies level, and the taxa level for Peloponnesos, which is here, and this is the total amount of taxa in Greece. Then we tried to work with the extent, the ecosystem extent for woodland and forests. So you see here in grid cells 10 by 10. These are the different floristic ecological regions in Greece, where the area cover, the extent cover, ranges from very high to very low in the different phytogeographical regions of Greece. And in the next map to the right, in the next map here, you can see the relative area cover. So it means the extent for woodlands and forest in relation to the total woodland and forests extent in each region. For example, in the area of Crete, where our 4th ESP conference is going to take place in October this year, in 2022, you can imagine that this area, we have a very high, cover of woodlands and forests in relation to the woodlands and forests in the whole floristic region. So we have a relative extent, a relative area cover for the woodlands and forests in each of the regions. So we are trying to make some proxy indicators. Then we tried also to have, as a proxy indicator, the number of plant species, again from very high to very low in each grid cell. And the same is here, the relative number of plant species per floristic region, where we have the relative number of species in woodland and forests in relation to the total number of species in the floristic region, always in relation to the woodlands and forests. Then we tried to have to play with two parameters, which is the extent from the one point of view and the total plant species. In this case, we have the total plant species, and here we have the total plant species in relation, again, in the woodlands and forests. And we, of course, proceeding to work also with the other ecosystems, but we have tried to do this with the forest and woodlands, which mostly are the best known, not only in Greece, but also, as we have seen in Fernando's presentation, also in other European countries, European member states. So we are trying, here you see that we have the same information, the relative number of species in relation to the extent and in the relation to the total species in the woodlands and forests in each floristic region. So now for the Peloponnesus, we have here you see as a first baseline reference, as a baseline for accounting, we have the different ecosystem types in Peloponnesus, our case study, and we have played in a way with a regional number of species, which means number of species in the Peloponnesus, regional unique species in the woodlands and forests. We have unique species in Peloponnesus in the ecosystem type woodlands and forests. How many are the endemics in the Peloponnesus, in the woodlands and the forests, and how are the endemics in the Peloponnesus, in the woodlands and forests. And the same we have done with the 7 ecosystem types, excluding the marine, for which we have no information since our area is mostly covered as a terrestrial area. So we have all these numbers, all these are ready. You see here, not only for the woodlands and forests, but also for the heathland and scrub, the total species richness, the endemic species richness for heathland and scrub, as well as for grasslands, and the same, of course, we have applied also for the other ecosystem types. So then for the accounting and valuation, based on an equation and based on some policy which is adopted by the Ministry of the Environment already from 2014, we will calculate the total biodiversity value for each ecosystem type. Here you can see for the woodlands and forests, which is adopted by the Greek Ministry, where the total biodiversity value, as we see here, V, is related, is a product of area, which is the ecosystem type area in hectares, multiplied by the naturalness coefficient for different types. Here you can see the map based on which we have the naturalness coefficient, and then P is the value, the euros per hectare, which means the maximum biodiversity value for woodland and forest, depending on, as we said, on naturalness, as well as on the extent of each ecosystem type. So integrating the area parameter, it gives us a straightforward solution to create accounting tables based on woodland and forest area change through time. So then we have this possibility. We're working now on to have the relative area, again for Peloponnesus, since this is our case study, for one ecosystem type, which is the heathland scrub, from very low to very high, again you see, and what is the net change between 2012 and 2018. Here we have all the equations that are used in order to have this net change from each time period to the next time period. We have data from 1990, 2000, and 2012 and 2018. So for each of these ecosystem types, we have the extent covered by, let's say, grasslands in the different time periods. And then if you see here for the woodlands and forests, we are going to apply the same equation, the same formula for past and present period in order to have the accounting tables. And of course, if we wish, we can also have future predictions using the climatic scenarios and management scenarios in order to have the future area change. Because in Greece, we're very much interested, of course, as all other European member states, also to find out how all these exercises will influence, of course, the future scenarios on management and conservation management under the climate crisis. Then we tried also to do some exercises using the data from the Natura 2000 sites. So biodiversity accounting within the Natura 2000 network sites. In Greece, we have about 30% of our terrestrial land is covered, designated as Natura 2000 sites. So here you can see in a higher resolution, I mean, this is the NATS 2, and the Peloponnesus is divided into NATS 3 areas, different prefectures. So in each case, we have noted here the MAIA level 3 in 2000, how many different ecosystem types at MAIA level 3 we had, 13, 16 we have in 2015, after a better exploration of the areas. Net change is given here. The same we have given for habitat types for the whole area of Peloponnesus. We see that in 2000 we had mapped and noted, we had recorded 37 habitat types of the directive of Annex 1 of the Directive 9243, and in 2015 we have 50. So we have a net change. Even at that level, we are working with a net change. The same we did with the priority habitat types in its period, and then with the species included in the IUCN threat categories in the two periods, and then with the Annex 1 species of the directive. Here we have only included the plant species, but of course we can include also the animal species and the avifauna species based on the birds directive as well as in the habitats directive. And you see that this information is also in a more detailed scale for the different prefectures at NATS number 3. And here you see that in the prefecture of Achaia, one of the prefectures we have selected, we are giving also the different ecosystem types, and for each ecosystem type within this prefecture, and of course in all other prefectures, we are giving the same information, IUCN, as well as the annex species of the directive. And of course the net changes are going to be interpreted, the gain or loss, with various, let's say, the wildfires, how much they have influenced the change, the loss of some species of IUCN category, as well as the wind parks. That's why you see these questions in wind parks and wildfires. Then we tried to do some exercise, because we are working also with the alien and invasive species. Here you see the invasive species occurrences throughout Greece, in the whole of Greece. We have, this is the number of alien taxa established, and out of which established we have 62% of the 457 out of this number of taxa in Greece. And of course, here we are giving the number of alien taxa in grid cells. Again, we have created a scale. And of course, the same we are doing now for the Natura 2000 special areas for conservation in the different in the different periods in 2000, 2015. And this is the ongoing project on the monitoring of habitat types and species in Greece, where a special metric will be included in the protocols for the people who are going to go to the field in order to collect new information of the presence of alien and invasive species in each protocol collected in the field. Last time we had about 15,000 protocols collected in the field within the Natura 2000 sites. And one more thing, this is almost the end, in order not to lose more time. We are working now with endemic, medicinal, and aromatic plants. So you see that again for Peloponnesus, we have extracted the number of endemics from Peloponnesus. We found out how many of these endemics have their own properties: aromatic, medical, traditional medicine, antimicrobial, environmental benefit, industrial. And then, of course, all these properties, of course, we can also have the ecosystem services provided by these properties for the endemic species of Peloponnesus. And of course, it's not always the case that we have endemics where known information, published information on the properties of these endemics are available. So we compared this with with other relatives of these species in order to find out the potential properties. And of course, this gives us also an information that is going to be transformed into ecosystem services accounts. Next steps is to integrate biodiversity accounting standards into current monitoring schemes, as I told you before, for the Habitats and Birds directives. I'm responsible for this Habitats Directive monitoring project for the following 3 years, to collect the biodiversity data that can support both the biodiversity and ecosystem condition indicators for accounting, to integrate biodiversity accounting into agricultural production standards reporting and monitoring, and integrate biodiversity accounting into post-fire restoration standards reporting and monitoring. This is good in order to that people realize the importance of accounting and ecosystem condition, especially for restoration after fires, which is one of the big problems throughout the Mediterranean region. Thank you very much for your attention.
Thank you very much, Panagiotis. I think that was a wonderful presentation. And again, I'm really impressed by the fantastic work that Greece has done, you with your team on biodiversity accounting. I'm quite sure that these are the most comprehensive biodiversity accounts that were developed in the MAIA project. So is there any, I'm so sorry again for the tight schedule, but is there any question for clarification to Panagiotis? Yes, I see 2 questions, that's okay. So we'll have 2 questions for this presentation.
I have a quick question, and I would be interested, is it possible to connect the work you already done with ownership data for the land?
Right.
Ownership. What the sector is the land on which the plants grow or the species live? Who owns the land, and is there a relationship between the management and the biodiversity level?
Look, we have different levels. All the Natura 2000 sites are within, the property belongs to the government, belongs to the state. So it's a state property. So within this 30%, the management is, the responsible for the management is the Ministry of the Environment, also with the organization about the environment and climate change. So in other cases, with stakeholders who are owners, with private ownerships, always we have some negotiations and then everything is okay. So the ownership, as concerns us the data, most of this data, the database about plants is, it is in our, as a scientists, we have created this database, but all the other data, the monitoring data, are national inventories, so which are available also to the scientists who have worked for this. All this data that we have said, it is in progress to make some publications until, of course, the end of this project. We are going also to publish, because only the reports are not sufficient, in my opinion. Everything in order to make a step beyond should be published, so that next project goes further.
Thank you very much, Panos. Very quick question, please. So one question, the last question, I'm afraid.
Thank you for the presentation. I had a question on the total biodiversity value for woodlands and forests. You mentioned that the price that was used was 120 euros per hectare for the maximum biodiversity value for woodlands and forests. So I was just wondering what was the criteria for this price to estimate the value risk? Thank you.
Look, the values, as I told you, it's not created by us. It is based on some scientific publications which have been adopted by the Greek government. I think it was from Italy, published work in 2014. And the Greek government, with some research organizations, they have elaborated and transformed the data for the Greek case, and then they have created these tables, which, for example, depending on the naturalness index, coefficient, they give different prices in the different forests. If you see the naturalness index, you will find out that the artificial forests are of less value, of course, compared to the natural forests, which are, we have multi-layered forests with high biodiversity, etc. So we are using this data because we cannot create everything from scratch. Of course, we have to, especially for the biodiversity evaluation, which is a very difficult task, and the biologists sometimes we have some problems in order to express in a monetary basis, the value of biodiversity.
Thank you very much. Other questions in the break, I'm afraid.
Yes.
Thank you, Panagiotis. That's great. Rix, please. Yeah, prima.
Thank you all for having me here. My name is Rix de Jong. I'm from the Netherlands, from the Statistical Office. And I'm going to show some results that we've been working on for the past several years. I'm going to focus on the biophysical accounts and indicators that we've developed from it. And from the very start, we have been working together with Lars Heijn and his team from Wageningen University. So it's really a joint effort that I'm going to show the results for. Now, so far, this shows an overview of what we've developed so far. So we have an extent account for 4 different years, which means we can develop time series. We have change matrices available. And it's now interesting to look also at how we can develop indicators based on these time series. For the condition account, we have 2 years available. Biodiversity account, we are working on an update at the moment. A carbon account for which we'll make a partial update. And then we have a range of ecosystem services for which we also have 4 different years of data available now. And I want to focus on the first one, the extent account, and on the ecosystem services. So for the extent account, very recently, we've been putting a lot of effort into analyzing the change matrix. So what kind of information can you really derive from that? We've also been testing new visual ways to represent those often complex data and complex tables. And we've been developing time series and indicators for monitoring purpose, for example, for the SDGs. So there's a lot of work in progress. I don't think you've seen everything, Lars, so I hope there are some surprises. Now, the extent account in the Netherlands, it has increasing policy relevance because in the Netherlands, of course, small country, a lot of people, we need more housing, but we also need to reserve space for climate mitigations, for example, to allow space for flooding of the rivers. But we also need to reserve space for renewable energy. And we have an EU obligation to further expand our existing nature network. And all of these things take space, and that's something that we don't have a lot of. So policy interest is high for this topic. Now, the extent map that we have for 4 different years now, it's you can see the example here. It shows 50 different ecosystem types, and it's based on a very detailed combination of a lot of different data sources. I will not go into the technical details here, but they result in a vector map, and then our working resolution for most of the ecosystem models that we've developed is 10 by 10 meters. So it's quite a fine and detailed map. We also include line elements. We also wanted to be able to include things like hedgerows because they are very important and we know that they are. So we've been putting a lot of effort into further developing the extent account and develop these maps and also consistently, make them consistent through time. Now, that was a map. This is a visual reflection of that same map. And here you can see that roughly half of the Netherlands are being used for agricultural purposes. A small part, the purple part, is, small, that depends on what you think. The purple part is the built-up area, so that's the area used for infrastructure, living, housing, economy. Then the green part is nature or semi-nature. So we distinguished here between forested areas and open nature and wetland areas. Of course, we can make finer distinctions, but this way you can actually read the figure. And then the blue represents the water. We only looked at the inland waters here, the fresh and the brackish waters. We didn't include the North Sea, because then the entire figure would look differently. And the very small strip at the top is the coastline and the dune areas. So this is roughly what the Netherlands look like. So we have a lot of agricultural land, and the rest is divided in the way you can see here. Now, there are many levels of information in the extent account, and we already saw some examples in the earlier presentations. To the left here, you can see what we call the green-blue space, and that is the area which is either blue, water, or it's green that you can actually access. So it's nature, semi-nature, but also parks, recreation areas that are green. And we expressed it here as the percentage of a certain size area. I think it's a 1 kilometer square here, and the percentage of that. So this is another way of looking at the extent account. And this information shows you where you can actually go as a person for recreation and have access to water and nature, semi-nature. To the right, it's a different figure showing the change between 2013 and 2018 of industrial areas. And here the reddish colors indicate where there's been an increase in industrial areas, data centers, distribution centers. There's a lot of controversy around those as well because they take up a lot of space. And here you can see where they've been increasing over this time period and where they've been decreasing. So that's another type of information. Now, here we looked at the concentration of the highly urbanized areas. So the figure to the left shows pretty much where the big cities are and how the highly urbanized areas are positioned in the country. So that's the figure to the left, again as a percentage of a certain radius. But to the right, this is a result from the change matrix. This is per province. It shows where in recent years, since 2013, urbanization has increased most. And that's actually the province in the center here, where the area of highly urbanized areas, it has increased by almost 20%. So it shows you where the changes are taking place. Of course, you can also look at this at the municipality level. You can zoom in as far as you want, pretty much. We already saw two Sankey diagrams. So I think everyone struggles with how do you show a change matrix in a way that you can actually see something, because you see all these lines shifting into something else. We tried a different approach. I'm not sure which one is better. So I'll try to explain this one. This figure shows the situation in 2013 on the rows, 2020 on the columns, and I don't know if you can see my mouse. Yes, okay. So what's missing is the diagonal, because what would be on the diagonal are the big blobs that show the area that has remained stable. But we're not really interested here in the area that remains stable. We want to look at the changes. So we removed those, and then all of a sudden the changes pop up in the figure. And the clearest thing you see here is actually also the least interesting part, because this is the logical transition between grassland and agriculture. That is, it's just part of normal farming practices that you shift between these two. So they're not the most interesting. Well, I don't have time to go through the entire thing, but as I said, the diagonal is empty. But if you look at the square, you can look at, on the line here, it shows area that has been turned into built-up areas and infrastructure, and what it used to be in 2013. So you can see here that public green spaces, grassland and agriculture, but also open nature and forested areas, they have been transferred into this built-up area and infrastructure. So this is just another illustration on how you can get information from the change matrix. You You can also look at it in another way, because as I said, we have all these pressures and all these challenges on how do we use the limited space that we have in the Netherlands. And so far, we can see that there's a decline in the agricultural land. So this map shows for each province what used to be agricultural land. So the size of the pie shows what used to be agricultural land. It has been transformed into something else. And the colors then show you whether it was transformed into built-up areas, that's the purples here, or nature, or water. These are the three main categories we looked at. Of course, you can also, again, look at the very high detail if you want. But the overall picture that you see here is that, in general, in every province except for one down here, most of the agricultural land that has been transformed into another ecosystem type was transformed into built-up areas and infrastructure. The one exception is here, where the green area, which is nature, is slightly larger. Now, then something about the ecosystem services. We looked at food and fodder crops and all the finer distinctions between these, timber production, then a whole series of, well, you can see them here. Lost the name. Type of ecosystem service. Regulating, thank you. Regulating ecosystem service. So water purification, air filtration, etc. You can see them for yourselves. And then we also looked at two cultural services when it comes to the biophysical, which is nature recreation and nature-based tourism. So I'm going to show some results for that. But I think we already heard that also in Alessandra's presentation. We want to develop indicators. And the reason for that is that, of course, we all go from data to models. And then we have a model, and then we use that to spatially allocate the position where ecosystem services are generated. And then we put all that data into an account. And that gives you the quantity and the changes, and you can monitor which services are provided by which ecosystem type, and that links nicely into condition. And we all know how the system works, and it's really beautiful. But the reality is that most policymakers are not interested in staring at a change matrix. And I supply use tables. I think there's only people in statistical offices who really like them. So we've been trying to develop indicators which give you more policy relevance. And these indicators are needed to translate those complex models and those beautiful spatial patterns that you also need to make something that is more easy to understand. What we also found is that there is a very high demand for data at the level of municipalities. So that is something that you also need to focus on. What can you do at that level? I think it was interesting what Carl said this morning, because you have all these different perspectives. And if you start developing indicators, you have to make a choice. Do you look at the perspective of what is nature providing for humans, or what is the value of nature itself? And it really depends on the question and the perspective you choose, what type of indicators are relevant. So some examples here. We have a nature recreation map. We also have it now for 2020, so this is an old map. And we express that as the kilometer of hikes in nature per hectare per year. And although everyone in the Netherlands recognizes the darkest green areas as the dunes and the beautiful forests that we have in some areas, nobody relates to this unit. So we translated this into the number of long hikes on average per person per year. And I think you can then get an interesting time series where the average person in the Netherlands apparently goes out for roughly 12 times a year to make a long hike with purely the destination nature. But in the COVID year with all the lockdowns, it increased heavily. So that's something you can get out then. Carbon sequestration. Again, we have a beautiful map with the tons of carbon per hectare per year. And of course, at the municipality level, it can be very interesting to zoom into the details of this map and see what is happening where. But to the general population, the tons of carbon per hectare per year doesn't mean anything. So here we expressed it as carbon sequestration as a percentage of the total annual IPCC emissions in the Netherlands. And then you can see that in normal years, we don't reach 2%. So below 2% of our emissions are captured by nature and vegetation that we have in the Netherlands. Again, an increase in 2020. And this is, of course, what happens if you combine more data, because this isn't that we planted more trees. This simply means that we had lower emissions in 2020 because of the lockdown. So that is something you have to keep in mind. If you add more information, then it can show something different, which is not necessarily nature-related. Another way of expressing this is that if you would want to compensate for the full IPCC emissions in the Netherlands, you would have to plant up an area that is approximately the size of 3 times the Netherlands. So it puts things in perspective if you look at it this way. Then I think the last one, air filtration. We've been looking and making maps for the reduction of fine particulate matter. The thing is that this ecosystem service shows a decline, because the official measurements show that air is becoming cleaner, and that means that the service is going down. And that is maybe not, of course, that's also true, and it's something you have to show, but maybe that's not really what you're interested in. So we looked at different ways of looking at this ecosystem service. So originally we looked at the number of kilotons of particulate matter retained per year. That shows a decline over time. You can also look at the percentage of the country where the World Health Organization standards, where they're met. That's also, I mean, it's interesting for policymakers, but if you live in the country, you actually want to know what it's like in your area. But of course you can look at this, and that's interesting as well. And what we did here is we looked at the actual contribution to the concentration reduction by vegetation. Of course, you have to then make some assumptions, but that's what we show here. And then you see a decline, which has nothing to do with the lowering concentration values, but which has something to do with the vegetation characteristics. And we don't know exactly what it means. We do know that we are losing forest in the Netherlands, so it could be that, which you're seeing here. It could also be that the location of the forest is different. Maybe it's further away from the main sources, so we don't know that exactly. But it is showing you a different story. So it is yet another way of looking at this service. Now, what the plans are for the near future is we want to identify relevant indicators for all these different accounts that we're working on at the moment. We're also working on improving and filling the Dutch MAIA viewer, which is a spin-off from the MAIA viewer that you all know. And we plan to, in the very near future, we organize workshops with stakeholders because we really want to improve the policy relevance. And we think on the one hand, the level of the municipality is something we should look at. And at the other hand, these different types of indicators. We're also working on the development of marine accounts for the North Sea and the Wadden Sea area. And we want to update and improve the biodiversity account. And we have now a strong focus on dissemination and outreach also to potential users. And thank you for your attention.
Some questions for Rixt. Online, perhaps? No questions, but we have time for 1 or 2 questions.
I have a question, Lars.
Sure. Online first then. Yeah.
Hi. Hi, Rixt. Hi, Lars. I was triggered by your statement about the large interests in accounting data from municipalities. And I would like to hear a bit more about it, what the intention is of the use. And on the other hand, I guess it's about planning. And on the other hand, whether the information you provide are more, let's say, macroscopic accounts are good enough to answer this need, let's say.
Yes, that's thank you. That's a very valid question, that last one. What we have developed in the Netherlands is we have a very large Beyond GDP program, and we make that at the national level. We also have developed it at the level of municipalities. So you can go through provinces down to the level of municipalities. And that includes a whole range of information, from health information and emissions and a lot of economic indicators. Also using some data now on ecosystems, so the percentage of green in that area, for example. And when we published this, we got, and we still get, lots of emails from those municipalities, like, can you develop more data? I mean, we can, things that we've been looking into separately is, for example, the carbon balance of a certain municipality. What does that look like? But also the total area of green space and how that has developed over time per inhabitant, for example, that type of questions.
Mm-hmm.
So, and then your question on, can we always answer that? Well, I mean, the honest answer is no. You always run into resolution problems. You always have, I mean, our models are top down, so you have information at a certain scale and then you refine it and you allocate it to those smaller areas. So you have to be a bit careful with the, especially with the communication when it comes to municipalities. Yeah.
Okay.
For the extent account, that's not a problem. But of course, when you look into services, you start running into that problem. Yeah.
Okay, thank you. Perhaps a follow-up. The examples that you mentioned are closely linked to climate policy, mitigation, adaptation. My feeling from the needs from municipalities is that they they care about climate, but not about natural capital accounting. But we can answer climate questions with natural capital accounting.
Yeah.
Is that the same story in the Netherlands?
Yeah, we have an obligation that municipalities have to be climate proof by some year. So when that project was just started in the Netherlands, we got a lot of questions on the urban heat effect, the urban heat island effect and runoffs, so surface runoff. So I think you're right. I think the primary interest is from a climate perspective, but also the welfare perspective. Do people have space still to recreate? How is that changing? So I think it's, but yeah, it's a focus on climate. Yeah.
Okay, thanks.
So I have a very, very quick and follow-up question, because I was about to ask you something about also the municipality accounts. So is there a demand from the municipalities, and are they planning to use the information you are producing to making some territorial planning decisions or these kind of things, or is something that you have,
Well,
if you have to look at it?
That is what we hope. So we hope that they will use this as a planning tool. Yeah. No, we asked ourselves exactly that same question. That's the reason we're organizing a series of workshops. We want to present, this is what we have at different levels, but what is it that you need? And that's exactly the focus of the workshops that we're organizing. So I hope in a few months' time we'll be able to report what the outcome was. Yeah.
Last question from Leo, I believe. Oh, answered. Okay. Well, last question then from online. Was that because I cannot see very clearly from this angle?
It's me, Lars. Hello. Thank you very much for your very interesting presentation. And in particular, I think the issue of air filtration ecosystem services, it's a topic where we really have to look, more in details inside, because I have a similar experience now while valuing this ecosystem service in the context of Switzerland. And then we realized that because in Switzerland, I don't know how it is in the Netherlands or in other countries, but in Switzerland, there are just a couple of dozens of stations where they measure air pollution, right? And then this data is used then in models to model and somehow to interpolate these emissions, right, over the territory. And recently I learned that these models do not account for the vegetation. If these models do not account for the vegetation, that means then the values which we get for each pixel, right, it's of air pollution, it's not it's a biased value, right? And it's in principle doesn't account for the presence of vegetation there. And when we try to figure out what is the contribution of vegetation in each particular pixel to air filtration, then we can get really some results which are far away from the reality. So that means actually we also have to look in these models, interpolating emissions and over special areas. That's, I believe, a very interesting topic. Thank you a lot.
Yeah, thank you. Yeah, I think the technical details of the model that we used, I mean, you have to make a basic assumption. You have to assume that in the Netherlands, most of the measurement areas for the air quality, they're located near to sources. So they're in the middle of a busy center road, and they're along highways, but not all of them. But that's where a lot of the measurement areas are. And then you have to assume for this model to work that that is purely the emissions, not affected yet by vegetation. And then you can look at the impact of vegetation in lowering this. But it is a model. I mean, it's not, this is not validated. We haven't actually looked into detail whether this is actually what's happening. So this is but I don't see another way of developing the air filtration model. So, but it's true. It's a problem you can run into.
No, I mean, fully agree with you. I just mentioned that it could be also an issue that in which we should in the long term look into, because these models, they may really have a major impact on the evaluation results, right?
I think we have to finish this session here. Thank you very much, Riks. Great presentation. And thank you for the questions, everybody.